For unit 10.1, we're going to look at the unit circle. But before we can do that, we've got to go back and take a look at some trig ratios that you would have learned in geometry, and then also introduce you to some new trig ratios that you may not have seen before. So remember that the basic trig ratios that you did in geometry include sine, cosine, and tangent. And the way that we remembered sine, cosine, and tangent and what the ratios are is through the little mnemonic device SOHCAHTOA. So you had sine and then O over H, C and then A over H, and then T and O over H. And remember that the O stands for opposite and the H stands for hypotenuse. So the sine of theta, and we're going to use the Greek letter theta instead of x to denote what our angle is. The sine of theta is equal to the opposite side, the length of the opposite side, over the length of the hypotenuse. Then the cosine of theta is equal to the length of the adjacent side over the length of the hypotenuse. And then finally our tangent was the length of the opposite side over the length of the adjacent side. And remember that you can then put these into your calculator to then find out what is the length of the third side, or if we needed to, what is the length of the, what is the angle measure for theta. We'll take a look at how to find angle measures in just a second here. Now the next thing we need to look at is the next three trig ratios, which are going to be the cosecant, the secant, and the cotangent. And these are all reciprocal ratios. That means what we're going to do is we're going to take the sine, the cosine, and the tangent, and we're going to flip them down into the denominator of each of these here. So the cosecant of theta is equal to 1 over the sine of theta. Then the secant of theta is equal to 1 over the cosine of theta, and the cotangent of theta is equal to 1 over tangent of theta. So that's the more complicated view of what cosecant, secant, and cotangent are. There's an easier way to look at this, and before I show you the really easy way, I want to show you how we get there. So if we just take the cosecant for example, we know that the cosecant of theta is equal to 1 over sine of theta. So this is the same thing as saying 1 over the opposite over the hypotenuse. And what we get now is a complex fraction. So we've got 1 divided by the fraction opposite over hypotenuse. So remember that we can take a complex fraction which is stacked vertically, and we can spread it out horizontally instead. So what we're going to end up with, instead of looking at it like this, is 1 over 1, which is exactly the fraction that 1 is, divided by opposite over hypotenuse. Now you just got to go back to the rules you learned about dividing fractions. Whenever we divide fractions, we're going to take the second fraction, we're going to flip it, and then we're going to change the division sign to multiplication. So this is going to become 1 over 1 times the hypotenuse over opposite. Okay? And then anything times 1 is just going to be itself. So this works out to hypotenuse over opposite. So you can see that when we're talking about reciprocal functions, all we're doing is we're taking whatever the sine function is, and to become cosecant, we're just flipping the numerator and denominator. We do the exact same thing for cosine to get to secant. So adjacent over hypotenuse becomes hypotenuse over adjacent. For the cotangent, we just take the tangent and flip those, so it becomes adjacent over opposite. So if we're trying to figure out, let's say that we're given this triangle here as an example, and we want to find out what all these trig ratios are. We're going to look at the sine of theta. So we're going to identify where theta is, and theta is this angle here. So we go opposite 5 over hypotenuse 13. So the sine of theta for this particular triangle is 5 over 13. Now if we want to find the cosecant of theta, all we do is we take this, the 5 over 13, and we're just going to flip that and it becomes 13 over 5. Now if we're looking for the cosine of theta, that's going to be, again, identify the angle, and then we're going adjacent, so the side that's adjacent to this angle is 12, and the hypotenuse is 13, so this becomes 12 over 13. To get our secant of theta with this exact triangle, we're just going to flip that, and it becomes 13 over 12. So you can see that this is not too terribly difficult here. If we are looking for the tangent of theta, we're going to go opposite over adjacent. So this becomes 5 over 12. If we're now looking for the cotangent, we're just going to take that 5 and that 12, and we're going to flip that, and we're going to get 12 over 5. For problem number 1, we're being asked to find the 6 different trig ratios given an 8, 15, 17 triangle with the location of theta in this bottom left-hand angle. So what we're going to do again is start with sine, the sine of theta, and we're going to say the opposite 8 over the hypotenuse 17. So we know that the sine of theta is 8 over 17. To find the cosecant of theta, we're just going to flip that, and it becomes 17 over 8. To find the cosine of theta, we're going to go adjacent over hypotenuse, so 15 over 17. To then find the secant, we go 17 over 15. And then finally for the tangent, opposite over adjacent, so 8 over 15. And then to find the cotangent, that's going to give us 15 over 8. Now let's say that we want to find the angle measure when we're given 2 side lengths of a right triangle. What we're going to do is we're going to use the inverse trig function. And the way that we're going to do that is we're going to start off again by figuring out, based on the location of our angle, are we using sine, cosine, or tangent? We really actually don't need to worry about cosecant, secant, and cotangent on this, because it'll just be a little bit easier to use something that you've already been over in geometry. So based on this location right here, we know that we have the opposite and we have the adjacent. So that tells us that we're going to use the tangent of theta. So we're going to go the inverse tangent, and the inverse is going to be signified by this basically like an exponent of -1, and that's going to be equal to the opposite 6 over the adjacent 8. When we plug that into the calculator, we're going to come up with that the approximate angle measure is 36.9 degrees. And again, the way you're going to do this is you're going to go into the calculator, and you're going to, if you're on a TI-84 or a TI-84 plus, you're going to go second and then tangent, and that's going to bring up inverse tangent, and then it's also going to bring up a parenthesis when you plug that in, and then you just go 6 divided by, and then 8, and then close the parenthesis off, hit the answer key, and it's going to give you a solution of approximately 36.9. So that's going to be something that we're going to look at once we get to the unit circle itself, and we want to figure out what is the relationship of a point on the coordinate plane to the origin. What angle does it make based on its location on the coordinate plane? In problem number 2, we're being given that if the cosine of theta is equal to 2 over 5, they want us to find what are the other 5 trig functions. So let's start off with the easiest one. If the cosine of theta is 2 over 5, then that means the secant of theta is going to be 5 over 2. That one's easy. The rest we got to do a little bit of work on. So what we want to do is go ahead and draw in a right triangle, and I'm going to label the theta angle down in the bottom left there, with my right angle being down in the bottom right corner. So since I know that this is cosine, I know that this is adjacent over hypotenuse. So this is going to be 5 here, and this is going to be 2 here. So the next thing I've got to do is I've got to figure out what is that third side. Easy way of figuring out the third side, use Pythagorean theorem. So we know that if this is x, then these are the 2 legs here. So we're going to go 2 squared plus x squared equals 5 squared. And so we end up with 4 plus x squared equals 25. And so x squared is equal to 21. And so x is equal to the square root of 21. So I know that that leg right there is going to be square root of 21. Now that I've got that third side, I can very easily find all of the other trig functions. So the sine of theta is going to be the opposite, square root of 21, over the hypotenuse 5. Then the tangent is going to be the opposite, square root of 21, over the adjacent 2. Once I've got all 3 of those, the other ones are easy to get. So the square root of 21 over 5 becomes 5 over the square root of 21. And the square root of 21 over 2 becomes 2 over the square root of 21. And that's all you got to do. For problem number 5, we're being asked to find the measure of angle theta. So again, what we're going to do is use inverse trig functions on this one. And so we're looking at this particular angle, and we know that we've got the right angle is there. So we're looking at the opposite and the adjacent. Opposite and adjacent tells us tangent. But this time, instead of using tangent, we're going to use the inverse tangent because we're looking for an angle measure. So the inverse tangent of theta is equal to the opposite, 26, over the adjacent, 11. Now, you're going to have to take out a calculator to finish this off. So second, and then tangent, and then 26 divided by 11, and we end up with 67.0. This is approximately 67.0 degrees right there. For this next section, we're going to look at how trigonometry interacts with the coordinate plane, and we're also going to introduce a new concept called the unit circle, as well as a new degree measure that we call radians. Now, I'm sure that there's been a time where you've been using a calculator and you were expecting to get a certain answer in degrees, and you got a completely unexpected answer from what you thought you were going to get. The greatest likelihood is that your calculator was set to radians instead of to degrees. So if you were expecting like 70 and you got 2.34 or something along those lines, that's most likely what it was. So let's look at how all of this works together on the unit circle. First off, along the positive x-axis, we've got something that we call the initial side. This is where our angles are going to start on the unit circle. And then we can either have a positive angle by going counterclockwise, or we can have a negative angle by going clockwise around the circle. Wherever our second side is, what we're going to call the terminal side, that's going to determine what kind of degree measure we've got. So let's say that this one just happens to be 160 degrees. So that means that the positive angle is going to be 160, but to get there from here, we've got to go 360 minus 160, and so we would have a negative 200 degree angle going in that direction. Okay? So each angle, we can either get a positive angle or we can get a negative angle. The absolute value of those, when we add them together, should give us 360. The next thing we're going to look at is the degree measures on this circle. So since our initial side is the positive x-axis, that means that if we just have this line, that's going to be 0 degrees. Now, as we go around it, again, counterclockwise, our angle measures are going to get greater and greater. So once you get to the y-axis, the positive y-axis, you've gone 90 degrees around that circle. If we bring it back around to the negative x-axis, now you're at 180 degrees. If we take it all the way down to the negative y-axis, that's 270 degrees. And then if we bring it all the way back around to the initial side, then that would be a grand total of 360 degrees. Because remember that there's 360 degrees around any one point, the point being our origin. Now, the next thing that we're going to take a look at is how do these relate to radians? So radians are always going to be a measure that we give in terms of pi. So if we're at 0 degrees, that is 0 pi radians. Okay? And then as we move around the circle, when we hit 45 degrees, that first stop is going to give us pi over 4 radians. The reason for this, if we follow from the positive x-axis all the way over to the negative x-axis, we can see that we've got pi radians would be equal to 180 degrees. Well, if you think about this, 45 divided by 180 is 1/4. So how many radians do we get? We get 1/4 radians, or pi over 4 radians. Now as we move to 90 degrees is half of 180. So what that tells us is that we've got 1/2 pi, or pi over 2 radians. As we move again down to 135, 135 is 3/4 of 180, so that means that we have 3 pi over 4 radians. And then again, as we get down to 180, we've got pi. Now, what you should notice here is that this is 1/4. This is the equivalent of 2/4. This is 3/4, and then this would be the equivalent of 4/4. So as we move another 45 degrees, we get to 5/4. Another 45 degrees brings us to 6/4, which we're going to reduce down to 3 pi over 2. Then we get to 7/4, which is 7 pi over 4, and then back around to 8/4. So if we make a complete loop around the unit circle, we end up back at 2 pi. So the x-axis is both 0 pi and 2 pi at the same time, just as it's 0 degrees and 360 degrees at the same time. Now, we've also got a few other marks on here. You can see that I've got a mark here and here that's 15 degrees from 45 on either side. So 30 degrees and 60 degrees. So why are we putting 30 and 60 on here? Why are we putting 120 and 150, 210 and 240, and 300 and 330? Well, go back to your geometry lessons. One of the things that we stressed in geometry was special right triangles, 30, 60, 90s, and 45, 45, 90s. And the reason why we did that is because they have a special relationship that you're always going to see, and then you also saw it a lot on the SAT. So what we're going to be able to do with this is we're going to be able to use points to then figure out what is the distance from, say, the origin to this point using a 30, 60, 90 triangle. And we'll get to that probably in pre-calculus. For problem number 1, we're being given a coordinate on the coordinate plane, and we're going to be asked to figure out what are the 6 trig functions, and then I also want you to be able to figure out what is the degree measure for this particular angle. So what we're first going to do, let's find that angle measure. The way that we're going to do that is we're going to determine, or we're going to create a right triangle. So we know that we've got the point 8, -6, and we're starting again from the origin. So if we go 8 units right on the x-axis, that's a distance of 8. If we go 6 units down, that's going to be a distance of 6. Now, since I've got a horizontal line and a vertical line, I know that I've got a 90-degree angle right there, which means that I can draw in a line from this point to the origin, and I'm going to have the hypotenuse of a right triangle. Now, since I've got a 6 and an 8, that means that this has to be a 10. The next thing that I'm going to do is I want to find the measure of theta right there. So if I have theta there, what I'm going to do is I'm looking at the adjacent and the hypotenuse, or actually I can use basically anything here. So what I'm going to do is I'm going to go ahead and use the first 2 that I had, the opposite and the adjacent, and I'm going to go the inverse tangent of theta is equal to 6 over 8. So I'm going to plug that into the calculator. So second tangent, 6 divided by 8, and then that comes out to, again, approximately 36.9 degrees. And since this is going clockwise, this is a negative 36.9 degree angle. Now the next thing I'm going to do is go ahead and fill in all of the trig functions here. So 36.9 degrees, the sine, opposite over hypotenuse, 6 over 10. Now, you don't have to reduce this, because if we were actually looking for what the sine is, we want to put that into the calculator as 6 over 10. Let's say that you were to try to reduce this on your own. Instead of making this 3 over 5, you made it 3 over 4 by accident. You're going to get the answer wrong. So just go ahead and enter this into the calculator to get your answer. Now the next thing we're going to do is the adjacent over the hypotenuse, which is going to be 8 over 10. And then the opposite over the adjacent, which is 6 over 8. Over here, this becomes 10 over 6. This becomes 10 over 8. And the cotangent becomes 8 over 6. Okay? And it's really that simple. All you've got to do is create a right triangle, label your distances, find the third side, and then you can use all of that information to find the angle measure that you're looking for. The last thing that we're going to do in this section is to convert degrees to radians and radians to degrees. So you need a very simple formula to do this. If we're looking to go from degrees to radians, we're going to multiply the degree measure times pi over 180. If we're looking to go from radians to degrees, we're going to multiply the radians by 180 over pi. So let's check out how this works. We've got 120 degrees. So we want to go from degrees to radians. So it's going to be 120 times, and we look at what do we multiply by? Pi over 180. And we can see here that this is 120 over 1. So we can cross reduce the 120 and the 180. 60 goes into both 120 and 180. So 2 times and 3 times. Now multiply across, 2 pi over 3 radians. So 120 degrees is 2 pi over 3 radians. Then for negative 45, again, we're doing times pi over 180. So negative 45 over 1 times pi over 180. Again, 45 and 180 will cross reduce. So this is going to reduce to negative 1, and then this is going to reduce to 4. So we're going to end up with negative pi over 4 radians. The next one, 5 pi over 6. We're going to multiply this, since we're going from radians to degrees this time, we're going to multiply by 180 over pi. So 5 pi over 6 times 180 over pi. Now what's going to happen is your pi's are going to cancel out, and then you're looking at the 6 and the 180. 6 will go into 180, and it's going to go into 180 30 times. So what we end up with is 5 times 30 for 150 degrees. Then the last one, negative 3 pi over 2. So negative 3 pi over 2 times 180 over pi. Again, the pi's are going to cancel out. The 2 and the 180 are going to reduce down to 1 and 90. And so we get negative 3 times 90 equals negative 270 degrees.